Hello and welcome to the Cold Finish Steel Bar Institute's teleconference seminar on the state of the art of cold finishing. We are coming to you from teleconferencing centers in Chicago, Illinois and Pittsburgh, Pennsylvania.
I also want to express my thanks to Cold Finish Steel Bar Institute, which has given me the possibility to describe general and specific aspects of wire, bar and section descaling. As a sideline, you may also be interested to hear about the technology which is available today in Europe. This lecture will analyze shot blast descaling of wire rods, bars and profiles, a technologically controlled and economical process in the light of our philosophy that any energy put into a descaling machine and not used for descaling only serves to destroy shot and machine. Considering the whole range of modern industrial techniques, there is hardly any one singular means or process available that can be used to substitute all previously employed methods aiming at the same target. This is also valid for the descaling of semi-finished products, as will be dealt with in the following. This lecture describes various methods, applications and installations, especially for wire rod descaling. Following a general outline of various systems, the lecture presents shot blast descaling as applied today as an up-to-date and versatile process. Shot blast descaling of wire rods and bars. I can be presumed that you already know the basic principle covering this process and the machines which are commonly used, and I will limit myself to describe specific applications and various points of particular interest. The abrasive usually consists of round or angular steel pellets, their size ranging from 4 thousandths to 40 thousandths. With high production equipment, the acceleration thereof is effected mechanically with blast wheels throwing up to more than 2,000 pounds per minute. Their working principle can be compared with that of a centrifugal pumps. The pellets flowing actually into an impeller at the wheel center are accelerated by the radial and tangential components of fastly rotating throwing blades. A slotted cage around the impeller of the wheel controls the exact position at which the pellets are passed onto the throwing blades, thus confining and directing the abrasive stream. The design of the blast wheels used by the various manufacturers of blast cleaning equipment already shows remarkable differences.
This is the influence of the blade shape, backward curved, straight blades, forward curved, and 4 straight blades. And this is the noise level generated by these blades. And you can see that basically there is no big difference between the different kind of wheels. This shows the intensity generated again by the different kind of wheels, and here dominates definitely this line S, which means straight blades. Here you will see the scatter of the stream depending on the different wheel concepts, and here again the straight blades are coming up with about 870. The forward curved blades are higher or scattering wider, and the backward curves are as well exceeding the straight blades. This shows the maximum intensity, and here the straight blades again dominate and come up with the highest values. The relative abrasive flow again shows the difference, and we see once more the straight blades to perform best. And that's the reason why I think you've chosen these straight blades.
Right, yes. For descaling wire rods and bars, the following shot blasting techniques are generally applied.
Okay, this is for the inline descaling, the 3 wheels arranged at the right distance with the concentration plates, and then multiple bar descaling with 3 wheels or 4-wheel arrangement. And this shows the coil-to-coil descaling machine with 2 wheels inside and 2 wheels outside for continuous descaling of coils.
The wire rods or bars in commercial grades and cross sections round, square, hex, flat are passed to and through the shot blast machine by means of straightening and drive units or other conveying means. The blast wheels are arranged both along the length and around the cross section of the blast cabinets. Due to their extensive use in the industry, the single-strand longitudinal blasting machines are well known, but single-strand coil blasting machines are now recognized as a viable way to clean coils of alloyed steel grades. Single-strand machines dominate today and replace the multi-strand machines as shown on sketch 2C, which have been widely used and are still best known. It has been found, however, that in the light of the state of the art, no more represent an economical option. Practical application of shot blasting technique. A survey of the extensive range of shot blast machine models for descaling wire rods and bars is given in Table 2.
This just shows the range of models giving the maximum power and what ranges can be covered in different shapes and sections.
Processing speeds are generally dependent on type of scale, workpiece shape, material quality and required surface appearance, including roughness. Thanks to novel GF concentration plates, throughput speeds up to 500 feet per minute are achieved in single-strand longitudinal shot blast machines. Additional technical and metallurgical details and features for the application of the process are
the average operating surface quality conditions.
First, second,
Single.
Fußnote.
Spray guide plates give optimum efficiency, main constituents being carbon, manganese, chrome, molybdenum, measurement with pedometers. Well, what you can see here is that with a single strand and the structural steels, you come up with through feed speeds in the range of 200 to 500 feet per minute with a roughness of approximately 15 to 25 micrometers RT, which we just can translate in RMS right now. And other alloys that have more sticky scale come down in speed to 200 feet or 260 feet.
Single-strand shot blast machines. These machines for wire rod and bar descaling operate fully automatically and without personnel if operated in line. Throughput speed of up to 500 foot per minute can be attained with a wire of a half-inch diameter. The development of these machines was triggered off by the demand for high-speed units to be installed at the feed inside of continued Schumacher drawing machines.
Well, this shows a typical inline arrangement with the payoff, the pre-straightener, then the Fisher descaler, and you may pay attention to the little space it takes up in front of the machine. This is the descaler operating in line with a 500 feet Schumach machine. This one even been fitted with non-destructive testing. And this is now a bar descaler where, and this is an outstanding feature, Fisher is achieving the through feed speed by just single strand descaling instead of having to go for multi-strand descaling.
Descaling without bending is a requirement for wires of high tensile strength as well as high alloyed steel that should not be exposed, cold work hardening and cracks being unacceptable.
Now this shows the coil-to-coil descaler. The coils are threaded through the machine. There will be two outside wheels to clean the outside surface, and the coil is threaded around two small inside wheels which clean the coil from the inside. And that's the reason why with this continuous operation 100% cleaning of the wire surface will be achieved.
The European wire mills, which supply the manufacturers of high-quality screws, bolts, studs, etc., were looking for descaling machines which could ensure a reliable and uniform cleaning of the coiled wires without going through the straightening and coiling operations. A successful solution was found, the single-strand coil machine shown here.
Well, this shows just another section of the machine, and you can see that here the operator is welding, is butt welding one coil to another. And this is a schematics showing the threading of the wire through the machine, the arrangement of the top outside blast wheels and the inside blast wheels with the jets coming down and their spread.
The working principle is based on two high-performance wheels located outside the coiled strand and two wheels blasting inside the spread-out coil. The screw-like rotary motion of the coiled wire, which is driven by the rotating camshaft, allows the whole of the wire surface to be evenly and thoroughly descaled.
This is
shown here are the position of the four blast wheel. Excuse me.
Yeah, it's correct.
This is the inside view of the blast room. It can be noted how the windings are well separated, this being a prerequisite for all around cleaning. Features of the GF concentration plates.
Here you can see the small inside blast wheels, as you mentioned before.
The system can be adjusted in seconds to any size of material, be it rounds, squares, hex or flat. Their main purpose is the increased coverage of the wire rod surface. This is achieved by focusing the stream of thrown abrasive as with parabolic reflectors. The angle of envelopment can be adjusted by changing the plate's position.
You see the action of the concentration plates. The workpiece in the middle here, the jet coming from the blast wheel being deflected, and instead of passing beside the wire, it is bounced off and will now hit the wire surface. And this is a similar process to what you would do with a parabolic mirror.
For proper design and application of concentration plates, it is imperative to have a profound knowledge of the principles of shot blasting. Knowledge of the fundamental principles and natural laws thereof only made it possible to develop the system ready for use. The main parameters are angles of impact and rebound of the abrasive, interdependent on each other.
Well, what does this mean?
Yes.
What?
Impact und Abprallwinkel.
Okay, well, it shows the angle under which the shot hits the material and is rebounced.
Descaling efficiency as a function of the impact angle. Next.
Now, the efficiency increases, of course, to 100%. Increases to 100% with an angle of 60 degrees. That means that's under this angle that you get the best cleaning effect. And with a smaller angle, of course, you will get less cleaning effect, but that means as well less wear if you look at it from the plates that may be hit.
Blasting intensity with and without spray guide plates. Basis 100 without guide plates.
Without guide plates, this shows the intensity around the wire circumference. And when the concentration plates are used, this will go up to almost 300%. The ideal intensity distribution would be a circular curve around the wire, but this circular curve is almost established by the use of the concentration plates. And this shows a specific configuration of concentration plates. They are not just flat, but they are parabolic to enhance on this effect.
Next figure depicts the influence of the position of the concentration plates on the blasting intensity. It is of major importance to have the plates properly adjusted to the diameter of the wire in order to obtain even intensity all around.
With fixed concentration plates, for instance, you would have them at a maximum diameter, and that means, let me say, at a maximum gap then of 10 millimeters. And you see that the intensity is very low. Now, by adjusting the concentration plates to the actual wire diameter, you increase this very low intensity to maximum values, as you can see here, with a 2 millimeter gap. And the fact that you can adjust these concentration plates to the wire diameter accounts for, in part, for the good performance of this equipment.
The adjustment of the concentration plates must be fast and reliable. It is done by just putting a pin in the hole marked with the diameter. During threading in the plates are opened by a pneumatic cylinder and closed when the leading end has gone through the machine. As a summary, compared to acid pickling, shot blast installations are compact and save factory floor space. They can be installed at floor level, generally without foundation pits. Expensive installations and means for acid regeneration and effluent disposal are not required. During the shot blasting process, there is no unwanted generation of heat. Thus, the possibility of changes in the composition and quality of the material is eliminated. Also, chemical reactions on the surface of the material are prevented to risk of getting pickling brittleness as a result of hydrogen diffusion in the outer layer of the steel is eliminated, and the surface is not contaminated by liberated carbon. With proper shot blast machine settings, the loss of material is negligible as compared to chemical pickling, where losses normally occur. Health hazards and damage to equipment and buildings by toxic and aggressive vapors are eliminated. Shot blast machine capacities comply with all requirements of modern processing plant. Inline installations ensure a rapid flow of production up to 500 foot per minute, and automatic operating controls eliminate the need for extra personnel. Continuous flow within one coil is guaranteed, going from coil to straightened and cut bars without intermediate accumulation, storage, and other handling. You can see that in order to obtain a thorough descaling of wire rods and bars, all that is needed by the operator of the line is to introduce the leading end of the rod or the bar into the line. As a conclusion, I would like to point out how much the service life of a blast cleaning machine is influenced by its design, which in turn results in low operating and maintenance costs. Let us look at the figures and specification of a machine running in a bright steel plant in Italy. The blast room length is 10 feet. Blast wheels drive 3 times 30 horsepower. Wire strand diameters 5/8 to 1 inch and 5/8. Drawing speed 120 feet per minute. Abrasive S 170. To tell the truth, we have been using for quite a while a new system which considerably increases the resistance to abrasion.
This shows here the cushion built up by retained abrasive. Here you can see ribs that hold it back. So what actually happens is the shot that has been accelerated by the wheel will hit this cushion off shot, which is almost like a heavy liquid, and is absorbed without ever touching the lining of the blast chamber. Furthermore, you will see that for the lower wheels, there are the deflector plates arranged that protect the upper part of the housing of the chamber from the jet of the lower wheels. These deflector plates here are originally concentration plates that are finally used up in this position. This shows the arrangement of the deflector plates. The lower wheel throwing the shot upward, and the shot, after having cleaned the wire here, will now be caught by this plate and deflected downward, where it will hit the cushion made up of the shot.
Coming back to the above-mentioned machine, here is how it looks after 20,000 machine running hours.
That is the line he is referring to. And now you can see the inside arrangement. This is the material to be descaled. That's one of the guides. And this is the shaft controlling the position of the deflector plates. And as you may see, it's a very neat arrangement. And even after so many hours, these shafts and their protecting sheathing is still in excellent state. What? Backward?
Yeah. The guiding funnels have been mounted for approximately 2,000 hours and the guide plates for approximately 4,000 hours. The average monthly maintenance time for the whole machine amounts to 10 man-hours for a 10-hour daily shift. This is a left-hand side view of the blast room.
And here again you will see this cushion made up of shot.
This is a view of the original lower screw conveyor after 20,000 hours.
Maybe you can see here that even after 20,000 hours, there are still marks on the edge of it from the original machining. So the material has been very, very resistant and properly protected.
The original buckets are still mounted on the elevator belt. Here's the worldwide activities of George Fisher. I thank you for your attention.
Thank you very much, Mr. Erath, Mr. Gussman. Gentlemen, any questions for Mr. Erath or Mr. Gussman? Yes, in the back of the room.
On the shot blast, you showed a picture of them descaling some coils and saying 500 feet a minute. But actually, that was probably equivalent to 5 passes, the way the coil was arranged. Then a little later, you showed a picture of another machine cleaning at 170 feet a minute. Can you still clean in 1 pass at 500 feet?
Okay, let me answer your question. The top speed of 500 feet per minute can be achieved in inline operation when you are actually going straight line through the descaler into a drawing machine. With the coil-to-coil descaling, the maximum speed that you could achieve in threading through the spires would be in the range of 200 feet per minute. So this is a descaling process more suitable for alloyed steels where the advantage of avoiding the cold working is of essence, but not so much for free cutting or carbon steels.
I got a question, Bill, like this.
Okay, can I go a little bit further then?
Sure.
On the concentration plates, you showed them up quite high. Doesn't the shot the rebound kind of interfere with the incoming shot?
I think that must have been a
Would
mix
you
up
repeat the
with
question, please? We did not hear the question.
Could you repeat it?
In the single strand blasting, the concentration plates, in the center of those, the bar was up quite high, several inches, several diameters up into the concentration plate. Did not the rebound of the shot interfere with the incoming shot on the cleaning? Didn't the rebound from the side of the concentration plants kind of flood?
I got your question. Let me just translate it. Ist relativ hoch drin. Frage ist der Rebounds. Würde der nicht den entgegenkommenden Strahl schwächen? Well, your argument is very logic, but Mr. Era tells me that in actual fact they haven't found this to slow down the incoming jet and to reduce the efficiency.
Putting this program on has been a learning experience, I think, for the Institute, as well as the subjects that were presented. And I'd like to thank everyone for being here, and it was a pleasure for me to be here.